Hello everybody. I'd like to welcome you back to my layout based on the Clinchfield model railroad in N scale. And this is, as you can see here, this is the book that gave me the inspiration for building the layout. It's based on Model Railroader magazine articles that started in December 1979, I believe. And so what they did is they compiled all the issues, I guess maybe 12 issues or so forth, and they end up making this one book. So it gives you a lot of details and bench work and let me see, wiring and stuff. But obviously this book is very dated, so since I've had the layout many years, maybe 20 years, but it was in storage for maybe 10 years or so. And because of obvious, let me see, DCC came out, and so the wiring has been modified. And I'm a bit of very interested in the electronics and such, so I've put more work into the electronics than I have into building the scenery and stuff. But the track work is very reliable, no derailments and that type of thing. So I focus more on the electronics. That's where my expertise is. So this video is going to be more about, since we're starting now 2019, so it's going to be a bit of a review of what I've done in the past year and some of the my future little electronic projects that I'm going to be working on. So just to give you an idea, these are the boards for turnout decoders. So each one of these boards, these are my original ones. That's why they're out here, because I've replaced them with Team Digital SMD84, which I'll show you a little later. But to give you a little bit of a breakdown, see, it's sometimes when you go to like older technology, it's easier to visualize how things were built, because nowadays it's like microprocessor, so you have it becomes smaller and less parts, and it's like a brain, and you're wondering, well, what's going on? And then, like I said, simpler times, things were a little bit more easier to understand. In this case, what you'll see here, I'll try to get the camera steady. This is a capacitor for capacitor discharge. I'm plugging in Pico turnouts coils, so they end up plugging into this bar with this bus here. There's a connector there, 25 pin. So it ends up, and these are power transistors. So each one will power one of the turnouts, left and then right. So there's 8 turnouts. So you have 16 selections, a left and a right. So the capacitor discharge will save up the current. And then depending on this one does have a microprocessor here that you program, or the factory programs it. DCC signal comes into this board, and that's it. Whatever you tell it to trigger the turnout will trigger, and it'll empty the capacitor, give the full charge, so that your Pico turnout will flip very well. So it gives you, this is easier how they did it back in the day with these SCRs. And so I had, and what was nice is because they're 8, if I had them, like in this case, I had them in the yard, so I would have, let's say, I think I have about 8 or 10 turnouts on this side and 8 or 10 turnouts on that side. So it made the wiring very easy, because the boards were right underneath this section, which is the best way. I find, putting a central panel somewhere else, because like they do have this panel here, or in this case, I ended up putting an LCD screen there, but originally there was a folding panel there. And let me see, I can probably find it in the book to give you a better visual. Yeah, okay, see, that's their panel there. And they had a board behind where they would bring all the wiring, and then they would create, let me see. Yeah, see, they would have these connectors like this, and these terminal strips, and then run everything through these bus wires. So now what happens is you would have a big connector between each section of the layout all around, bringing all that wire to that one panel. But now with the current technology, because you have DCC and LocalNet and ExpressNet and all of that, you can reduce the limit of wiring of bringing all, if these boards were somehow installed on the panel, then you have to run 3 wires to every coil all around the layout. That becomes a lot of wiring and connectors and a lot of fail points. So by connecting them directly to the just below here, and then just wiring them together, the boards from one board to each other with a LocoNet or to the DCC bus, it makes things a lot easier. So one of the reasons I went to I switched away from these boards. I mean, they lasted years and the great quality, good stuff. The thing is, because I wanted to start working, as you can see, the signaling. I've been making a few videos on the signaling, and the signaling is controlled by, again, it's a Team Digital boards. They're called the CSCE boards, and they have you program them with JMRI, and you give them the logic, telling that if the block is occupied or the turnout is flipped or the block ahead is occupied, what color to give the signal. So all of that, they're communicating, because now each board or each signal is a DCC signal, and then the logic on these CSCE boards have to talk to those signals, and sometimes they want to know, like, what is your it's a two-way communication, so they want to know what is your status, whereas DCC, it tends to be, it's just one direction. You talk to locomotives, you tell them what to do. You don't find out information from the locomotives unless you have like something enabled like Railcom, and that's a little bit more complicated. But ordinarily DCC is just one-way communication. So you can flip turnouts and you can flip lights or whatever, but one light doesn't know what the other light is doing and so forth. But with LocoNet, it's a two-way communication. And what I also like about the LocoNet, the signal from Team Digital, is that you don't need to have a PC running that software, so it becomes completely independent. So the thing is, now to be able to get answers from which direction the turnouts were flipped and such, well, again, like I said, these are DCC. You could just tell them what to do and hope that the turnout did flip and whatever, so you don't end up getting a feedback from it. But with the SMD84 turnout decoders, they work. I'll put one and go underneath the lamp here and show you a couple. Let me try and turn on the light here somewhere. This is the Team Digital guys. Hopefully you can see that. It's right here, this board. So they have a DCC in, and then they also have a LocoNet in and out. So you just daisy chain them to each other. So I have one here which controls 8 turnouts, and that's what I like about this board is the Digitrax board is LocoNet, but they could do only 4 turnouts, whereas this one does 8 turnouts. And then I have another one down here, and I have another one on this side, and then I have another one on the other side of the layout. So these are very close to each other. They run here's a bus here for the that goes to all of the turnouts, and they're all done the same way. But what's also neat about these boards is that you can there's a few things there. They have some inputs here. There's a little board here. Just a sec. Okay, hopefully you can see it. I have, it's like let me see, I'll show you in this place here. See, here's a board, connector, and on the other side there's some switches. So I have a harness that goes up and into that little panel there, right about here. Yeah, so it goes into that board. So what's neat is when you come on this side, you'll see I have here a little board with the switches here. But then I also have places where along the frame, in the here push buttons, then here push buttons, and if you notice there'll be a whole bunch of them around the layout, a couple in strategic places. So what's nice is it also gives you the option that locally, if you don't want to, from your throttle, you can type, because of DCC and your throttle, you can type in the address and hit but you have to know the address of that turnout. But in this case, it's like they're in the fascia, strategically placed, so you can say, okay, I know which button it is and which track I've labeled. So you just need to know the track number, and they're like A, B, C, D, E's. They go like that. This is JK for these last two turnouts or spurs here. So you just press the button and it switches. So you have your local buttons, you have your internet communication. So even if you have wired up, because I use the DigiKai DR5000 command station. It has a built-in Wi-Fi access point, so now you don't need to run JMRI to connect your cell phone to your layout. You can run the app, download the app, and from the app you can say, take the turnout address and flip it. But again, you need to know the turnout address. Unless you used, in my case with the Z20, I use the Z21 app on my phone, so you can create a map, a display of diagram of your layout on the tablet. Let me see if I got a version of that. Hold on. Okay, as I said, the command station is compatible with Z21 hardware. So this is Z21 mouse, and it's compatible. So what's neat is I've connected, again, it's a Wi-Fi mouse, so you connect it to your LAN, give it the same thing as the IP address of the device, and in this case I'm at the screen where I'm at selecting turnouts. So now I'm sorry for the glare, it's written the turnout 17, and then I can flip it. See, so that's that turnout. That's right, should be right there. So there you go, and have another throttle, because these throttles, they cost about $100. So that's it's reasonable, but also a little pricey. If you're a home guy, Arduino guy, and all that kind of stuff, there, home build, or like, you can build something for a lot cheaper. This one ended up costing me about $10 to build. This is based on an Arduino. Right under here, you'll see this is called the Arduino D1. That's it has a Wi-Fi connectivity, so which is neat because I have one of these boards set up as a command station, and this one is set up as a throttle. So again, with Arduino software, you can turn these boards into turnout decoders, signal, whatever you want, Arduino. So, and then this board on the top here, this is a little battery board. So what I'll be able to do is put a battery pack on here, then plug it into this connector. So then it'll be, truly wireless, because now if I want to run it, I actually have to plug in a USB wire from here, to the wall wart and run it. But this is a nice little simple one that just cost a few dollars to build, and it's Wi-Fi, like I said, and it'll connect to this station here. Let me see. I'll try and give you a screen and turn it on. Hold on. Okay, here we go. So here I open the Z21 app, which excuse me, which is supported by the DR5000 DigiKai command station. So two things you have to be able to do is to connect to your Wi-Fi. So you would see the under your Wi-Fi settings the DR5000 serial. That would be the connection. So you log into that, and then you have to give the IP address of the in the case of here excuse me, I think it says Z. Let me see if I can go back in here. Sorry, settings, Z21 settings. See down here in this corner, you have to give the IP address 192.168.16.254. That's usually the default address of the DigiKai DR5000. So you have to give the IP address, but first you have to have selected, let me see, in your Wi-Fi to connect to that device. You can't just be connected to your router and over your internet. You have to connect through here. So let me see if I open that Z21 back. I think play. Yeah, see, so as I flip that turnout, this is a simple map there. It's not obviously my layout, but just I just did a circle, added a quick turnout. That's address 3. So if I hit 3, then whatever my turnout that is address 3 will flip. So that gives you an idea how this app interfaces with the layout. So as I was saying, controlling turnouts, you can control it through there. You control it through, I have another throttle I'm using. Hold on. Okay, so here it is. Hopefully I'll be able to operate this with, because I only have two hands, one on this phone here and one on the throttle. So let's see. Yeah, so it's a nice little color display. Gives a little icon for the locomotive. You can turn on, see, this is the headlight. And then I can I have 4 functions set up as the 4 default functions. So now I'm on the locomotive 92. This is sound locomotive, so let me see. There you go. Bell. So the icon here turns green. Sorry, focus. And then you have access to the four functions. You can flip to a turnout screen, which is here. And now I could flip the turnout one way. I can select the turnout one direction, the other direction. Let me see. It's weird how they do the software on this guy. You have a button that'll go up hundreds, thousands, I think tens. Where is it? Tens and ones. Yeah. So it's not too, friendly there. It's like, how do I get back or whatever? Anyway, hit the button, you go back. Oh, there you go. So let me see. If I go on the ones, oh, that went to 100. Reset. Maybe I have to press the tens. Okay, 21. Let's see. Oh, there it goes. So you get a little graphical change. So that's another way to, again, wireless, costs maybe $10 to build. And so, you buy a few of these, build a few of these, and everybody's happy. Again, you can always use your cell phone, but, something like this is cheaper. And so, I'll be right back. Okay, and just to finish off with the turnout decoders, the other thing I wanted to say was, what's neat is that you can program through JMRI. You can program each one of the outputs to the address you want. They don't have to be like 1 to 8. 1, 2, 3 like consecutive. The first turnout could be depending on how you wire it. So sometimes the wiring it'll be convenient. Let's say however you bring the wiring, you want to bring from one turnout, second turnout, however you bring it to the board. Then you notice, oh, turnout. This is turnout 1. This is turnout 3. This is one turnout 7. This is whatever. But you can actually reprogram the SMD84 Team Digital Turnout Decoder to say, okay, that's turnout 1, turnout 2, turnout 3, or in my case what I did is I did 1, 3, 5, 7, 9, 11, 13, and then on the other side I did 2, 4, 6, 8, 10, 12, like that. So east and west, and so that's what's neat. And so it becomes easier for you, let's say if you want to remember the turnout addresses, how they are, you might want to, and then you can say, okay, in my yard, the addresses are, let's say 100 and up, and then if it's, let's say somewhere down there, you can say, okay, it's north, the turnouts are going to be numbered 200 and up, and 300 and up, and whatever. So you can program any address you want to any one of the turnouts using that system. So that's what I liked about that. I'll show you some other projects I was working to. I'm going to go on the other side of the layout. Hang on. Okay, so the other thing is, since creating all the logic using JMRI to do the panels, the turnouts and the turnout routes and such, and the DCC addresses and the locomotives and all that stuff, you end up getting data. So then it becomes once you numbered all your blocks and so forth and all that, you can end up. In my case, what I did is I used a Raspberry Pi W. So this tiny little computer over here. It's connected to a power, then the USB wire goes to the layout there. This is the wire here going to the USB, and then this is the HDMI to this big screen. But the other thing is I also did play around with was I ended up connecting this monitor here. This is a little Raspberry Pi monitor, 2.7 inch, and you can hook it onto there, and you can actually run some software. So JMRI is installed on that Raspberry Pi, and I have this. I put this screen to operate, just to get everything going. Because I might, if you want to have a layout, you say, oh, I want to create the what is it there? The server, built-in server, so you can use a JMRI app on your phone to connect to your layout. Well, a lot of times with even with what is it, the DCC++ command stations, you need to connect to JMRI. You need to be running the server software on a PC or laptop or whatever. So in this case, you can run that software on this Raspberry Pi. So it gives you that functionality because that Raspberry Pi is also Wi-Fi enabled. So it creates a wireless access point. So you're not actually connecting to your router, your home router. You're connecting directly to this device, and it runs the. Let me see if I can see on my PC. I'll go to. If I could minimize something here. Yeah, you can see up here in the corner. See, I'm running some Raspberry Pi stuff, the throttle app, and then a server app. And this is all the stuff that's going on, the commands that's happening. So then I can open back my, let me see my panel. Oh, that's not what I want. Where is it? Oh, yeah, this one. So now what's ever happening on the layout, you see what's here. The blocks are occupied, the turnout, what turnouts are flipped, what signals are, so everything matches that. So that's a great thing. The other thing what was neat is I was able to even connect this to the layout, since as I said before, with the throttles, you know how the throttles, the DR5000 has the built-in Wi-Fi access point. So this guy, you could connect it, you don't even need to connect through a USB cable. You could, if it runs on battery or, again, power or even battery, whatever, you can actually connect this to the layout through the wireless access point. And then you say TC in the settings for configuring a JMRI, you would say instead of connecting to COM port 1, you would say connect to an IP address, and you would end up setting up the a little script with gets a little technical, sorry. But there's at the JMRI site, I just followed some installation they had, and everything works. So you put in the IP address of that command, the Wi-Fi access point on the DR5000, since it's built in, and you end up connecting to the layout so that becomes like a wireless thing. So again, you wirelessly connect instead of with a USB. The HDMI you don't need if you're connecting a little monitor like that, and then the power, it's 5 volt, or you can plug a battery pack, so you can actually have your whole JMRI installation in your hand, and you walk away with it as long as it's within range of your layout, the command station there. It'll operate. Okay, moving on. As you see in previous videos there, you've seen this is one of my panels for selecting the routes, and this is a panel to show the block detection. So I'm going to be working on I built some projects, LocoNet projects. Let me see if there's one handy here. LocoNet. Not sure if you've seen one of these boards. This Geert Gieben, he created this, and it's a LocoNet board, and it's 30 or 32. Let me see. Yeah, 32 inputs. Yeah, so you would connect switches, and then based on the switch, you would control something on your layout. So that would be inputs, but they're not outputs to turn on stuff like lights and flip turnouts and stuff like that. They're just inputs. But he built a new circuit which is almost the same footprint. He's using another processor. This is the 16F1519, and I think this new one is 18F4620. So he just posted something about that just during the Christmas holidays. So I'm going to be looking at building some of those, and eventually what I'm going to try and do is I'm going to try and make a panel where, like I was saying last time, is combine the two. So you won't be looking at, you'll see green if the route is selected, red if the route is occupied, and maybe a flashing red or maybe a flashing red if the route is selected and occupied. So combine those two together. And again, what's nice with this type of wiring here is, like you see this panel here has only one USB wire. This is a USB wire that goes into the box, and that's it. Not USB, sorry. Network connection, or RJ12, or I should say, maybe to be more precise, it's a LocoNet connection, but it's also bringing power. So not only is it a LocoNet connection, it's power. and then a wire, in this case I just wired a wire out, and then it goes into the next box. And then this box is just the same thing. It's local net connection and the power. That's all that's really going into those boxes. So you can unplug them, bring them out around the layout, plug them into another local net and power connection, and away you go. So the wiring is really reduced. The other little circuit I have going in the background here was down here. See, I even unplugged some parts. This is a MQTT circuit, which I've spoken about that in other videos, and I'm following a project by a guy, Hans Tanner. So he's building some projects, and he's building and right now he's actually building a CTC panel, which with the strip lighting and stuff like that. So I'm going to be using some of his information to create my new panel, either using the new board like that, or using his board with the. I'll see how I put things together. And let me see, what else do I have? These are my little LocoNet, single LocoNet boards that I built. USB, I mean a video on that online. So, and the last thing is, like you see, I had a laptop, or not a laptop, it was an old type of PC. I had a foldable LCD screen, and so I actually pulled the screen out and was able to jam it into the layout there. So that's pretty neat. But I find that I'm not using it so much. Again, with the tablet and JMRI, I can start since that as you see on that PC there, it's running the JMRI. But then this also becomes available remotely. So from a tablet, you can just log into the web page. It creates a web page. So you go to the web page and you'll see all that map, and you can bring it around with you on the layout as you go. Or you can have a tablet attached to the layout on a battery. On a stand, and access it that way. But I like in my case, I like the redundancy of having a physical panel here that when I turn on the power, everything works. The signal, everything works. I'm not relied on the computer or software that you might crash or whatever. But I also have the opposite, not the opposite, but the option to use the computer. So this is what's nice based on the technology you buy, because sometimes you might have turnout decoders or signals that are, let's say, not LocoNet or whatever. So they're only, you can only operate them through, like here, again, these are some more turnout switches that are, and this will update that panel. Like, see, for instance, if I take root N here, let me see. Oh, I have something unplugged on the other side. Hold on, I have to go plug that in. Okay, see, so let's say N, get back to here. Yeah, see, so the root selected. This is actually a display here, but let me see. This is giving you the LocoNet information of what's happening. But just, it's my first attempt of writing some code, and I got the information, but it's not like displaying it properly. I have to put the right punctuations or whatever so that it's written properly. But like the information is coming out. See, I'll flip another one. It'll go through and give all the commands. See? So you see some activity that's going on. So yeah, the last thing I wanted to show, we'll see if the wire is long enough here. Here I started building we'll see how this ends up coming up. A little tunnel with some traffic, and I'm going to have some railway crossing here. I was inspired by Rhythm Railroad. He bought and he did a few videos of the Azatrax grade crossing. With so not only are the gates going up and down, but the lights are flashing, and you have multiple directions and such, and there's sound to it. So there's a lot of stuff. So I might end up purchasing that Azatrax guy, or I might end up using one of the Team Digital CSCE boards, because those boards, as I said, they control my signals. Like you can see the one there by the portal, but it's multifunctional. So it also has inputs for switches and detectors, and it has outputs for just regular LEDs, and it also has output for servo motors. So I can actually wire it up to my layout so that not only will it control the signals, the block signals, it'll do all that grade crossing stuff. So and then it has input, so I can connect a little board that does sound. Whereas the AsiTrack, everything is built in. What's great about AsiTracks is everything is built in. It's like a plug and play type of thing. Just follow the instructions and away you go. But with the CSCE board doing the grade crossing stuff, it's a mind bender. You got to figure out how to which input does what, and how do you set up the servos and all the lights and stuff. So it gets a little bit more difficult, but it gives you more options. So I'll have to see how I progress with that. So that'll be one of my next projects for the new year, is the grade crossing part. Okay, thank you for listening. Bye bye.